The main aim of this experiment is to observe the nature of spectra of sodium atoms with one valence electron using a grating and spectrometer, also to determine the wavelengths of the sodium spectrum. In 1991, Niall Bohr was able to explain what the electrons were doing by creating a model specifically dealing with the behavior of electrons in the atom. In this experiment, we are going to observe through the procedure as follows. This is the experiment setup of one electron spectra, which the spectrometer will be used. It is connected to the power supply, and the mercury source of light is used. This is a colorimeter, which makes a light parallel to each other when coming out to this path. That's why the light source is infinite. This is a telescope part, which we can see the image from by looking through, and can be rotated at different angles. The rotation can be measured using this circular vernier caliper. This is a grating. This value we can calculate the grating element. It will be mounted if we place this grating. The deflection occurs as we can see in this figure. The light falls normally on this slit and different order of image was formed. Initially we have seen a white thin lines where n is equals to 0, which have lower intensities because intensities has been divided into different parts where both sides of this image we can see the first order and second order for the different color. We can measure the lambda for a particular order and take the average of the particular color and get the frequency of the wavelength of the light. The important thing that we have observed from the experiment after the result was tabulated, we did notice that the double nature of spectral line is more easily observed in the n is equals to 2 order than n is equals to 1 order spectrum due to greater angle dispersion in the higher order.